use the distance formula in R1. That's just a number line, one-dimensional. Use the distance formula in R1 to verify that the midpoint between two real numbers, x1 and x2, is given by the formula midpoint equals x1 plus x2 quantity divided by 2. So this is the supposed midpoint. We'll call it M. So clearly this formula gives us a real number. This is another number in R1. And to verify that it is the midpoint, we want to check the distance between x1 and M and the distance between x2 and M and make sure that they are equal. Now the distance between 2 points, the distance between the points x1 and x2, for example, is given by absolute value of x2 minus x1. And that is the same as absolute value of x1 minus x2. So it doesn't matter which order you put the 2 points in the absolute values here. You subtract and take the absolute value. Subtract in either order and take the absolute value. So for example, the distance between the numbers 2 and 5 is the absolute value of 5 minus 2, which is 3, or the absolute value of 2 minus 5, which is the absolute value of negative 3, which is 3. So now we want the distance between x1 and M, and we want the distance between x2 and M, where M is this guy, x1 plus x2 over 2, and we want to show that those are the same. So this is the absolute value of x1 minus M, which is the absolute value of x1 minus the quantity x1 plus x2 divided by 2. Common denominator of 2, so 2x1 divided by 2 minus x1 plus x2 divided by 2. And now subtracting, we have 2x1 minus x1 makes x1, and we have minus x2. And the absolute value of a fraction, the absolute value of a over b, is the absolute value of a divided by the absolute value of b, and the absolute value of the denominator here is just 2. So this is 1/2 absolute value of x1 minus x2. So it's half of the distance between the two numbers. And we need to just verify that x2m has the same distance. So we can do x2 minus m, and that's going to be 2x2 over 2 minus x1 plus x2 over 2, and subtract. 2x2 minus x2 is going to give us an x2, and negative x1 minus x1 all over 2, and this is 1/2 absolute value of x2 minus x1, and the absolute value of x2 minus x1 is equal to the absolute value of x1 minus x2, and so we can conclude that the distance between x1 and m is equal to the distance between x2 and m, and therefore m is the midpoint of x1 and x2. The distance between x1 and m is the same as the distance between x2 and m, so m must be right in the middle between x1 and x2. Assuming here, of course, that x1 and x2 are different numbers. So maybe we should have said between the distinct real numbers. Because if x1 equals x2, then x1 minus m will equal x2 minus m for any m. Okay.